Good afternoon. My name is Cilian Roden, and I'm one of a team who have studied Marl lakes for the National Parks and Wildlife Service over the last 10 years or so. And this afternoon, I'd like to explain to you why these lakes are important and what's their present day conservation situation. You tend not to think of these lovely large lakes such as Loch Corrib or Loch Derg as being something very special. We're too used to them. In the middle of Ireland, there's perhaps 600 square kilometres of lake surface. Most of these are in limestone with a high alkalinity. They're formed partly by the glaciers, partly they're karst features, which possibly date back to the Tertiary, I'm not sure. And many of them involve underground discharge or underground streams discharging into them. Many, if not most, are famous trout fisheries and not so often commented on. They're scenically very beautiful. The idea that the midlands of Ireland have a dull topography is the idea of people travelling on the motorways. It doesn't bear out closer exploration. Here, for example, is Loch Cara on the western fringes of the Central Plain. There are three types of very important habitats in the Midlands: the raised bogs, turloughs, and marl lakes. And in ways they all have in common, they rest in hollows on the glacio-karstic surface. The Marl lakes, at least, are found throughout the Central Plain, from Meath to Mayo and from Clare to Sligo. A wonderful example of them is in the south of the Burren, just north of Corofin town. These lakes, though not large, are all but pristine and are exemplars of what Marl lakes should really be like. The Marl lake habitat is very important, and it's included in the European Habitats Directive as type 3140. And indeed, many Irish lakes are now designated as special areas of conservation. But unfortunately, the habitat is threatened. To start with, it's not common in Europe as a whole. In fact, in some countries, it's all but extinct. The British, for example, are very worried about its future in the UK. The cluster of lakes in the Irish Midlands is perhaps the largest cluster until you get east of Berlin and into northeastern Germany and Poland. As I said, many of them are threatened either by sewage discharge, which was a problem in Loch Ennell, arterial drainage of all the big cut over raised bogs, and unfortunately, intensification of agriculture. So for this reason, National Parks and Wildlife are very concerned about their future. And because of this, they have financed a series of surveys, which we've been fortunate enough to carry out, to see what is their current state and what is their future prospects. So here you have various members of the team. Standing on the left is Paul Murphy, beside him is Jim Ryan, and with us on that day is Anya O'Connor, who works with National Parks and Wildlife. And then in the inset, Jim Ryan at work. So our particular surveys, we surveyed about 30 lakes over that period, the 10 years. We've emphasized vegetation more than water chemistry because the EPA do such a good job on that. And unlike many surveys, we've used snorkeling and even on rare occasions, scuba. What's interested most to us has been species composition and the distribution of these species. So we've gathered very precise data on charophyte and cyanobacterial crusts. especially on species composition, which is often not covered in these lake surveys. And this is a very important point, because as these two elements constitute the great bulk of the lake vegetation, many surveys, purportedly of the lake's vegetation, report very little. Using this data and associated data, which we get from the EPA, we've devised a series of conservation indicators and used that to draw up a conclusion as to the ecological status, the conservation status of these lakes. Now, that's not to say we're the only people carrying out these surveys. The EPA, Inland Fisheries, and indeed other workers have carried out some very important surveys long before we started our work. But to start with, how would you recognize a Marl lake? Well, the first point is water clarity. In a good Marl lake, you can see plants growing down to about 12 meters. It's much greater than what you get in most lakes, where transparency of perhaps 3 meters would be the norm. Second point is the vegetation is very strange. You don't get the normal array of flowering plants in a pristine Marl lake. You get instead a very strange cyanobacterial calcareous crust covering the rocks. And that in turn is followed, as you go deeper, by different bands of charophyte species, with only a few higher plants or vascular plants in the mix. And then on top of that, though we know less about this, there's a very distinctive fauna. To start with, full of game fish, salmonids. Secondly, unusual species such as the crayfish, and all of these feeding on an invertebrate fauna, including snails, a variety of aquatic insects, especially mayflies, and as we're now starting to discover, some very unusual species indeed, including this beetle Octavius nilssonii, which is only found in a few Irish Marl lakes, possibly in more when we look, and in 1 or 2 other stations in Sweden and Italy, indicating just how specialized this habitat is. Another feature is that underwater springs discharge into many of these lakes. A lake in the Meath, West Meath border, Loch Bain, has a magnificent underwater spring which discharges at a depth of about 3 or 4 meters and is surrounded by a variety of unusual mosses. Now, there's more work to be done on these springs, but I think it requires the combination of scuba divers and hydrogeologists. So here's a quick introduction to the vegetation of Marl lakes. Close to the shore, you'll get the cyanobacterial crust, this orange-colored deposit you see in the top left-hand photograph. Then to the right, you get a species called Caracarta, growing down to about 3 meters. And then lower left, you get another species, Cararudus, which forms a large swathe of vegetation down to 5 or 6 meters. And then below that again, species such as Cara contraria and Cara virgata. But not alone is this a very distinctive and repeating vegetation, which you get in most good Marl lakes, several of the species are apparently rather rare. Caracarta, its center of distribution, is in Europe, is in Ireland. Cararudus, common in Ireland, very rare in most of the rest of Western Europe. Cara denudata, practically unknown outside Ireland. So in a sense, the vegetation of Marl lakes, though less spectacular than that of the Burren, has many of the same specialized geographical distributions. Now, the lake can be defined or can be divided into a number of vegetation zones, which you can see in these graphs, which show the depth of vegetation on the vertical axis, and the depth of light penetration on the horizontal axis. This gives you sort of the ecological niche of each species. And as you can see, Caracarta, the top left-hand species, only occurs in the surface layers. In contrast, Caravergata, below it, only occurs along the bottom. So each species has its own particular distribution. What seems to control the vegetation of these lakes is the depth of light penetration. In short, the clearer the water, the more developed they are. And as you can see in these two graphs, where you've got euphotic depth, the depth of light penetration on the horizontal axis, the number of species of charophyte increases with euphotic depth, and the density of cover, what percentage of the bottom is covered by charophytes, also increases with euphotic depth. So euphotic depth apparently is the driver of Marl Lake vegetation. And then what drives euphotic depth? From our work, we've concluded that both total phosphorus and lake water color are the important factors. As you can see in the upper graph, the lower total phosphorus, the greater the euphotic depth. And similarly, water color, which is the amount of dissolved color in the lake, the higher the amount of color, the lower the euphotic depth. Now, that's important because what drives total phosphorus? Runoff from sewerage, septic tanks, and agriculture. What drives water color? Runoff from peat bogs, especially peat bogs which have been cut over. So two very common activities in the Irish Midlands both pose quite severe threats to our Marl lakes. Combining the two, you can come up with an ecological index. It's very empirical, but as you see from the graph, it works rather well. That the index of color and total phosphorus decline as it increases, euphotic depth declines. Similarly, with the amount of charophyte cover in a Marl lake, also declines, but declines not linearly, but in a step-like fashion, up to a value of about -0.5. Isn't a great decline in charophyte cover. Above that level, charophytes disappear. So you seem to be looking at a step change in the ecosystem, that the charophyte and indeed the Marl lake, the Marl cover, the crust, remain more or less constant in cover to a certain point, and then both of them collapse, so that in the lakes with a high index, in other words, high total phosphorus, low water color, this Marl lake ecosystem disappears. So it seems that you can measure the decline of these lakes by the absence of the crust and the charophyte vegetation. Here you see a photograph of the bottom of Loch Mask, which is apparently in difficulty. We're not altogether sure why. And you can see, instead of charophyte crust, bare rocks. But look carefully at the shape of those bare rocks. They consist of an erosion pattern, which is often called egg box weathering because of the ridges and hollows. So we're arguing in this last part of the talk that that egg box weathering is the consequence of the growth of the cyanobacterial crust, or the Krustenstein, as it's called in German. Here are two photographs from Loch Cara at about 2 meters depth. They seem to be the crust covering rock. When you break the crust, the rock isn't there. Apparently, the crust has the capacity to dissolve away the rock. possibly by a buildup of carbonic acid at the base of the crust. We don't know. But remember, that crust seals the rock from lake influence and from physical erosion. So a good guess or hypothesis is this is the effect of the marl, of the crust. A far better example is found in Muckina Loch, where you have a series of what appear to be boulders, but when you break them open, really resemble Easter eggs. They're totally hollow inside. So we assume that once upon a time there were rocks here, but the crust, which is very well developed, has actually dissolved away the original rocks. Now, more work is needed on this habitat, but it strikes me as being very unusual and something that really hasn't been worked on, either in this country or anywhere else. A PhD student, Philip Doddy, who's now got his PhD, was told during his viva that basically this was totally new work. So here in Ireland, we have a very unusual habitat that needs further research and is threatened by total phosphorus and watercolour increasing. An even stranger example is in Loch Corrib, where when you remove the crust, again at depth at about 2 meters, so we're not talking about wave erosion here, you get this extraordinary pattern of hollows and ridges and very sharp pinnacles and edges. We postulate this is the result of weathering, biogenic weathering underneath the crust, and is a hallmark of Marl lakes. This is, by contrast, limestone in the lakes of Killarney, where you don't get crust being formed, and lo and behold, the naked limestone erodes in an utterly different fashion, with sharp edges certainly, but large areas of smooth, flat rock. So we take that as indicating that the egg box weathering is only associated with Marl lakes where the cyanobacterial crust grows. A hypothesis to be proven, but if true, it has very interesting consequences because it allows us to detect lakes that formerly were Marl lakes but are now polluted. So the future of our Marl lakes is very bad unless we control total phosphorus discharge from agriculture, sewage, and the discharge of very coloured water from cut over raised bogs. If we don't get a handle on that, as my slide suggests, the last we'll see of our wonderful Marl lakes are a few odd stones with the classic egg box weathering and a memorial to what is one of the more interesting and important Irish habitats. Thank you very much for listening to me.